Hello everyone. Today we will discuss about P&ID, that is stands for Piping and Instrumentation Diagram or Process and Instrumentation Diagram. As we know that in engineering design section, P&ID is a master document for each and every department. So to do the engineering design, we must know about P&ID diagram. Especially for instrumentation, this is very important document because our further engineering will be based on the P&ID only. So whenever we will work in any engineering design company, then we need to know about the P&ID. What is P&ID? P&ID, as I told you, P&ID stands for Piping and Instrumentation Diagram or Process and Instrumentation Diagram. So P&ID is an important engine document that shows the interconnection of process equipment and instrumentation to control the design system. P&IDs provide the primary schematic drawing used for detail engineering. P&IDs are fundamental to the maintenance and modification of the process that is graphically represented. At the design stage, the diagram also provides the basis of the development of control schemes like hazardous and operability study. For processing facility, it is a graphical representation of key piping and instrument details, control and shutdown scheme, safety and regulatory requirement, basic startup and operational information. So this is a live document. Whenever you will start your engineering, you will start with P&ID and throughout the project, even after project also, in running plant, P&ID update time to time will be happen. Just like whenever we will move a piping, we will add anything in the plant, so that P&ID will be updated accordingly. What does a P&ID include? So whenever you will see a P&ID, so it consists of all information about the processes. There are so many data will be available, like mechanical equipment with its name and number. Also, some data about the mechanical equipment will be shown in the P&ID, just like its a capacity, its a design conditions, like at what design pressure and design temperature it will be manufactured. Also, its material can be mentioned, and what is the process of this mechanical equipment, that will be also indicated. So whenever we will see the P&ID, then we can get the major information about the mechanical equipment, and especially for the instrumentation it is very important because there are so many instruments will be on the mechanical equipment. So if you are doing the engineering of that particular instrument, then you should know about the mechanical equipment's details. Even we can also get these details from other mechanical department documents, but from the P&ID also we can get the major information. All valves and their identifications. There will be so many types of valves. Some control valves, on-off valves will be there. Also some isolations valve will be there, and their identification, in the sense their symbols will be there. So based on P&ID, we can know which types of valve is used and what are the control valves, what are the isolation valve or manual valves are there. So from the P&ID we can get this basic information about the valves. Process pipe size and identifications. In P&ID we can get the information about piping. If you see any plant, then there are so many piping. So there could be a different size of pipes, there could be a different material of the pipe, different design condition of the pipe also. So based on the P&ID, we can know which types of piping is used, and accordingly we can do our engineering, because our instruments will be on either in line, just like flow meters. Flow meters are inline items. So whenever you will see the P&ID, there are so many flow meters will be in line. Control valves also will be in inline. Some instrument will be mounted online, just like pressure gauges, pressure transmitters. So to do the detail engineering of these instruments, we must know about the piping. That details we can get from the P&ID. Some miscellaneous items we can know about in P&ID, just like vents, drains, special fittings, sampling lines, reducers, increasers and switchers. Permanent startup and flush lines. Flow directions. It is very important. Which line is starting from and going to. This information also we can get. Interconnection references. Control inputs and output interlocks. Seismic category. Interfaces of class and changes. Quality level. Enunciations input. Computer control system input. Like whenever we will see the P&ID, then you can see there are so many types of signals will be there. Some signals will be going to the control system and some are the coming from the control system. And there will be different control system, like there will be process control system, there will be safety instrumented system, there will be emergency shutdown system also. So these information we can get from the P&ID. Vendor and contractor interfaces. This is very important things. So there will be scope defined, like what is the scope of contractor, what is the scope of any particular vendor, that will be clearly defined. We can get these interfaces. Identification of component and subsystem delivered by others. So few packages will be delivered by others, like maybe some things will be in client scope, will be some other vendor package scope. So that can be clearly mentioned in P&ID. Intended physical sequence of equipments rating or capacity, as I mentioned you on the top in mechanical equipment. So there could be so many types of equipment, like mechanical equipment, process equipment, heaters, all those things will be there. So we can get details about that in P&ID. So for knowing the P&ID, whenever you want to review the P&ID or you want to know about the P&ID, you must know about the symbols. Symbols and identifications are very important to learn the P&ID. So whenever you will work in any project, then you will get the bunch of the P&ID. In that bunch of P&ID, some starting pages will be of legend sheet. It is called legend sheet. So in legend sheet, there will be some identifications, there will be some signals, there will be some symbols also. So that symbols or identification will be clearly clarified in the legend sheet, so that whenever you will review the P&ID in detail, then if you don't know about any particular instrument or any item, then you can go back to the legend sheet and you can check what is it is. So you can cross verify with the legend and in your P&ID, so that you can know about that particular item. So for reading the P&ID, must we need to know the some symbols. So there are some valves symbols. As an instrument engineer, valves are very important items for us. So there are some symbols you will use or you will see in the P&ID, like some important valves, like gate valves, gate valve, hand operated, globe valves, needle valves, butterfly valves, ball valves, plug valves. So these are the valves symbols are there. So whenever you will see these types of symbols in your P&ID, then you must know about that. This is the globe valve, or this is the gate valve, or this is the ball valve, right? Because there will be no any mention like that this is the gate valve, just symbol will be there. So you must know this is the globe valve. And suppose you don't know about any particular valve, then go back to the legend sheet and check what is the symbol indicated for, so you can know about. So these symbol you must know. As I told you, some basic valves you will see in almost every project, like globe valve, ball valve, butterfly valve, gate valve, needle valve, plug valve. So these are the basic valves which are used every projects. And some also symbols of valve will be there, like relief valves, angle valves, and solenoid valves. So these are the symbols which is mentioned here also. These are the important symbol you will see in P&ID. Instrumentation symbols. Particularly for instrumentation department, there are so many symbols will be there. First, for the signaling, there are so many types of signal will be there in your P&ID, like hard wiring signals, wireless signals, fiber optic communications, digital communication signals, ultrasonic signals. These are the commonly used signals will be there in your P&ID. So we must know which are the signal indicated for which instrument or which process. Accordingly, we will do the engineering. Like whenever we will prepare the IO list, then we must know that we are preparing for the hard wiring instruments. And if you are doing the engineering for wireless instrument, then you must know how many, what are the wireless instrumentation indicating for, so that you can categorize it in your engineering. Some ultrasonic signal will be there, some FO, fiber optic communications will be there. So we need to know how we can communicate these signal to our system. So whenever you will do the detail engineering, then this category will required, or these identification you must know. So as clearly mentioned in this PPT, there are so many types of signal, like electrical signal, sonic signal, pneumatic signal. Yes, this is the also very important signal. Pneumatic signals you will see like this. So wherever any line will be crossed by these signals, then you must know this is the pneumatic signals. This is the electrical signals. This is the tracing lines. This is the pipeline signals. That means this is the major pipe, your main pipe is going through. And if any other line connected to the major pipe, if it is thin with respect to this pipe, that means it is the branch line. So these types of symbols you will see in P&ID. Also here is some instrument related symbols. In short, this first, it is for indicator. Wherever you will see only the circle and there is a tag number inside the circle, then you must understand that this is the local indication. This is the local indication. So just like a pressure gauge, any pressure gauge will be indicated by only circle, and in the circle the tag number of pressure gauge will be mentioned. But any signals which is going to the control system, so that will be connected to the system also, like any transmitter. So transmitter will indicate locally, but its signal will be going to any system. So its signal will be going to any system. We will see in P&ID. So these are the some like instrument indications, like TT means temperature transmitter, TI means temperature indicator. It is also T, sometimes it can be mentioned as TIT, temperature indicator, indicating transmitters. This is thermocouple, flow indicator, flow transmitter. So these are the types of instrument symbols will be there in your P&ID. And whenever you will start working on the instrument related job, then you must know what are the instruments are there. In your P&ID there could be different types of instrument. Suppose flow meters. So there could be a different flow meter. For example, ultrasonic flow meter, magnetic flow meter, Coriolis mass flow meter, Venturi meter, pitot meter, orifice plate, restriction orifice. These are the main instruments which are used in your projects. So we must know by the symbol that this is the these types of flow meter. Then again for temperature instruments. So by P&ID we must know about this is the temperature gauge, this is the temperature transmitter, this is the temperature element. So that could be clarified from the P&ID, because whenever you will do the material requisition of any particular item, then you must know about that particular item in P&ID. For example, suppose you are the owner of the vertex flow meter of the projects. You are the material requisition owner of the vertex flow meter in your project. So that means every vertex flow meter in your project will be designed or developed by you. Means you will do the detail engineering of that vertex flow meter. So first of all, what you will do? First of all, you will identify where it is, like how many vertex flow meter in throughout the P&ID. For that, we must know about the symbol of the vertex flow meter, so that we can count the exact quantity and we can design the exact number of vertex flow meter that is required for us. Similarly, if you are doing for the magnetic flow meter, then you must need to know about the magnetic flow meter, like by its symbol. So in short, you must know about all the symbols of the flow meters, valves, temperature instruments, pressure instruments, switches, level instruments, analyzers, detectors, so that whenever you will do the engineering or you will prepare any document, suppose you are preparing the instrument index, then how you will decide this is these types of instrument. That means you need to know about the symbols. So these are the symbols indicating for any particular instrument. These are some equipment symbols. Although these are the not as much important as instrument related symbols, but yes, in detail engineering, these are the symbol are very important. Sometime you must know about the detailing, like you must know about the mechanical data sheet of the equipment. So, and whenever you need to work on this, like suppose you are installing a thermowell inside a tank, or you are doing the engineering of any radar type level transmitter, so you must know about the equipment details. So at that time, that equipment will be important for us. We need to know about its process connection, its sizes, its nozzle locations, every details we needed. So these are some equipments which are used in engineering projects, like in refinery, in LNG projects, petrochemical types of projects. So whenever you will work in any project, so these types of instrument will be familiar with you. These are some vessels and some heat exchangers you will see in your projects. Basic P&ID symbols, some ejectors, turbine drivers, some pumps like it's centrifugal pumps. This way you will see very widely in your projects. Now come to the important points for instrumentation review, because this training is especially for the instrumentation engineer. So whenever you will work on any engineering project, then you must know what information we can get from P&ID, especially for the instrumentations. So I have listed out, like these are the information we must know whenever we will review the P&ID or we will work on the engineering task. Like symbols, as already discussed, we must know all the symbols of instrumentation so that we can understand this any particular item. It's a name, it's a type, and by the symbols we can know the instrument types. Instrument tag number, we must know about the instrument tag number. So in the meantime, we can discuss with live P&ID, so that it will be help to you to understand. As I told you the symbols, so you can see, if you know about the symbols, so this is the any flow meters. So if you know about this symbols, that this is indicated for orifice flow meter, right? So this is the orifice flow meter. And if you know this symbol, then you can mention the instrument type. This is the orifice flow meter. And where is the tag number? Tag number for element, the tag number is 62FE8086, and for transmitter it is 62FT8086. So this is the flow transmitter and this is the flow element. So what is the flow element? Orifice type. and then a signal is going from transmitter to the control system. So this is the process control system. Signals from transmitter is going to this control system. A tag will be created in control system and it is known as 62FC8086. So again a question like what is the signal it is. So as per the IO list lectures, you can say that this is the analog input because this is the transmitters. So transmitter signal types are 4 to 20 milliampere. That means this is the analog signals and it is coming to the control system. So as I told you that whenever you will decide any IO type, then you assume that you are in control room or in control system. So that means this is the input and this is the analog input. So what will be the IO type? This will be the AI. So this is the flow transmitter. This is tag number. So by the symbols you can identify the instrument type. Again the line number. Line number is very much important. Line number in other word pipe number. In P&ID you can say there are so many types of lines, though there are so many linings are there. Some lines are coming, some lines are going. Okay, so they each and every line have its particular number and there are so many information in line number so that you can get some information from the line and you can utilize those information in your detail engineering process. So what is the line number? You can see this is the line number. I am highlighting it. This is the line number. In next slide we will discuss in detail about the line number, but you must know that this is the line number and this line number will be same for this to this, even though up to those location where a break will be mentioned. Like whenever a break will be mentioned, then there will be mention of break like it is a class break or it is a size break. So the line number will be same until any break mentioned on this. Just like if you start from here, this line number same, this line number same, but this line number same. But here you can see there is a reducer. So reducer means what? There is a change in line size. And what is the reducer size? 8 cross 6. That means this line is reduced from 8 inch to 6 inches. So this is called reducer and this is called line number. Equipment details. So in every P&ID there will be some equipments also. So equipment details will be mentioned in the P&ID. Just like there is a equipments. It is a E5002A. So about this equipment there will be some basic information mentioned. Like you can see what is this equipment. So this is the BRU, the gas brine cooler water exchanger. And what are the basic data? It's a duty mentioned here, surface area mentioned, design pressure and alternate design condition, design temperature, alternate design temperature. This information mentioned here. So this information is very important to us. For example, suppose any instrument is mounted or connected with any equipment. So we must know the design condition of that particular equipment because the same design condition shall be suitable for the instrument also. If we will not include that design condition in our instrument, then what will happen? Maybe our instrument will be fail. That cause the dangerous situation in the plant. So we always satisfy to our instrument to meet the design condition of the equipment. Not only for the equipment. Suppose our instrument on the line or pipe, then instrument must comply the design condition of that particular line or pipe. Okay. So the equipment details will also be mentioned in P&ID. Okay, so this is the P&ID page, one P&ID page, and this is the working area. You can see this is the working area, and there is some note will be mentioned here. This is in bottom, there will be a title block. There are so many information will be on title block, like it's a P&ID number, project number, and the P&ID process, client logo, client name, and these information is for revision block. This is the revision block, like how many revisions happened for this P&ID. As I told you, P&ID updated time to time based on the requirement. So all the revision of this P&ID from the starting to the that particular time, this P&ID's revisions details is mentioned here. Okay, so these informations, even the contractor or consultant name, logo will also will be there here. So this is the title block. Title block is important for us because whenever we will do the engineering, and suppose for the P&ID there are so many revisions happen, so we must know what is the latest revision. Maybe the latest revision mentioned here, but after that also some changes can be there, and that changes can be captured on any particular MOC. MOC is called management of change. Like P&ID, after the latest revision also it will be in markup. So this revision block is important to know what is the latest revision of the P&ID, so that we will not miss any important informations. If by mistake we will work on the any older version of P&ID, that could mistake in our engineering, and that could be a wrong engineering. So always update, always know about this information, so that any like mishappening is not there.